back to Orlando Math Learning Academy. Today we were talking about linear inequality in two variables. As you are learning intermediate algebra, you learn how to solve one variable linear inequality, and the strategy to do that is to do the same way as you learn as you solve this linear equation. You isolate the x value and you get the final answer. However, the final answer is not just one value, it is a bunch of value, and we can represent those value on number line, or we can use interval notation to express the answer of linear inequality, or we can use algebraic expression to get the answer, okay, to represent the answer. Something like this. So let's do a quick recall. If I have something like 2x plus 3 greater than 5, okay, then I isolate the x, right? The term with x would mean I have to subtract both sides by 3, so I have 2x greater than 2 and x greater than equal to 1. This is a bunch of values. This is a set. As long as the x greater than 1 or equal to 1, it satisfies this linear inequality. And this expression we call a algebraic expression. And this expression can be represented with a number line. Okay. Something like this. And I have to use the dot because it's equal. Okay, so this is called graphical expression. Or or we can use interval notation to express the answer, something like this, from 1 to infinity, and I use the bracket. It means I include the 1, the endpoint. This is called interval notation. Okay, so if I add another, actually, no, not really add. The basic linear inequality most of the time is in the standard form. Okay, in the standard form, not really in standard form either. The basic linear inequality has one variable, okay? And now we have two variables, so they become linear inequality with two variables, and that inequality can be written in the standard form or a slope-intercept form. Okay, so today we're talking about linear inequality. Linear inequality in two variables. You already know the slope-intercept form of the linear equation y equal to mx plus b, right? Or I can give you an example like y equal to 2x plus 5. Now, if I replace the equal sign with one of these, then it becomes linear inequality with two variables. Okay, so let's replace the equal sign with this one. So the equation becomes a linear inequality with two variables. Okay. Because we have variable I and we also have variable I. So the method to solve this must be graphical because we cannot use algebraic method to solve linear inequality in two variables. Okay, and because it is linear inequalities is written in the slope-intercept form, so in order to solve it, we have to graph the linear equation first. Okay, so I will graph the linear equation y equal to x plus y. Okay, so I'm going to graph this 1, 2, 3, 4, 5. I use the rise over run method. Going up 2, going to the right 1. So I have like this, and I have a line. Okay, this line represents the linear equation y equal to 2x plus 5. Okay, then how we solve the linear inequality y greater than equal to plus 5. Okay, so you see that the line over here, it divides the coordinate system into two parts. The upper part, the part that above the lines, and another parts that below the line. Okay, so I can pick one of the point on each side and plug it to the linear inequality. As long as it satisfies linear inequality, that side, that part will be the solution of the linear inequality. Or I can use a tricky way, kind of cheating way, if it's greater than equal to, or it's greater than, the part I'll pick as the solution of this linear inequality will be above the line. So I will shade all the part that above the line. Okay. So any point here is the solution of this linear inequality because you pick any point on this part of the coordinate system will satisfy this linear inequality. For example, I will pick another one point for you. Okay. How about if I pick 1 and 9? Okay, let's do -1 and 9. Let's pick -1 and 9, and I plug it into this inequality. Let's see it satisfies or not. Okay, so 9 I plug it in here greater than equal to 2 times -1 plus 5. So become 9 greater than 2 -2 plus 5 is 3, and 9 of course greater than 3. So it satisfies this linear inequality. Okay, and the solution of linear inequality of two variables is a point. Instead, it's a bunch of points instead of a value. So that the difference between the solution of linear inequality and the solution of linear inequality of two variables is different from the solution of linear inequality with one variable. In one variable, it's just a bunch of value. It's not a point. Okay, and a bunch of value can be represented on interval notation or graphic expression or algebraic expression. However, you cannot represent a bunch of points on the interval notation. you must represent those points on the graph, of course, right? That's why the solution must be the solution of inequality in two variables must be a bunch of points on the graph on the coordinate system. Okay. Now let's do another example. So this is the first example. Example 2. If I have something y less than um, y is less than negative 3x plus 6, for example. Okay. And the way I solve this, of course, must be graphical. So again, I have to graph the linear equation y equal to negative 3x plus 6. Okay, the same way as we already learned for for graphing linear equation. y to 6 is 6. 1, 2, 3, 4, 5, 6. And we go down 3 unit. 1, 2, 3, and go into the left 1 unit. So instead of having a solid line as this one, now this linear inequality does not include the equal sign, so we have to use the dash line. Okay, and because it's less than, so must be below the line. Okay, below the line. Some student is very confused about which part is above the line, which part is below the line. So in that case, you must pick the point. Okay, as long as you pick the point and you put into the inequality, and as long as satisfy the inequality, then that will be the part of the coordinate system you want to pick for the solution. Okay. Okay. And now so far all the example I have here is in the slope-intercept form of linear equation, right? Sometimes it could be written as using the standard form of linear equation. Example 3. Something, for example, like this. I have 4x plus 3y greater than negative 1. Okay. This is also linear inequality with two variables. Because you see x and y is a variable. However, it is written in a standard form of linear equation, not the slope-intercept form of linear equation. And the method we do is also graphical. We have to convert it to slope-intercept form. Okay, so we have to convert into slope-intercept form and graph the linear equation. Okay, then pick the part that satisfies the linear equation. All right. So I want you to pay attention to some point when you solve a linear inequality with two variables. First of all, if the inequalities symbol is greater than or less than equal to, it means the line will be a part of the solution. as the example 1 right here. It means that all the point. It means that all the point on this line are also the solution of this inequality. Okay. However, the point on this line is not the solution of the inequality here. Okay. Second, if the inequality symbol is greater than or less than, it means the line is not a part of the solution. Okay, so in this case we have to use a solid line. Okay, and over here we have to use dash line. So as long as it's satisfied, the part that satisfies the linear inequality, you will set that part and you consider that part as the solution of the inequality variable. Okay. Okay. Example 4. I want to do one of the word problem. Something like this. Let me pick one of the problem in the book. Let me see. Okay. How about we do number 10, page 174. 174. Number 10, page 174. Okay, let me read it out loud. Anna owns a restaurant on Danube River in Budapest, Hungary. The restaurant is famous for their chicken paprikas and their goulash dishes. The chicken paprikas dinner sell for $9. Okay, let me do a quick summary here. Chicken paprikas. I never heard of this before. Paprikas. It's my first time. Know this. Dinners sell for $9 plate. Okay. And the bowls of goulash. I don't know what the heck goulash is. Goulash. I don't know what it is. I never heard of that. Sell at $5. Okay. And over here it says let x by the number of chicken dinner and y number of bowls. X represent the number of chicken and y represent the number of bowls. Okay. And a sale for 2 items must be at least $1,080 in order for her to meet the expenses. Write a linear inequality that represents how many of each type of chicken dinner and bowl goulash she must sell to cover her expenses. So at least $1,080. Okay, that's what she wants. In order for her to meet the expenses. So part A, we want to write the inequality that represents how many of some type of chicken dinner and bowl of goulash she must sell to cover her expenses. Okay. So over here we see that we have $9 for a plate. So if X is the number of chicken plate, so the total will be 9X, right? Okay. And the total, this is $5 for bowls. So Y bowls, the number of bowl is Y, so be 5Y. And we want at least, you see, at least, this is the amount of money for the chicken dinners. This is amount of money for the bowls of goulash. And all of this must be at least, so it means greater than equal to $1,080. Okay, because at least it must be greater than or equal to. Okay, so that is part A. Okay. Your inequality using a solid line or dashed line as appropriate. Set the region that contain the solution. Label the tick marks. And the axis. Okay, that's easy. So part B, I just go ahead and graph this. You see that over here 1080, so that is the pretty big number. So I just mark it. That must be the y-intercept point. So let me see. I have to convert into this slope intercept from 4. So y should be greater than or equal to negative 9x over 5 plus 1080 over 5. So it's greater than to negative 5x plus 1080 divided by 5 will be 216. So 216 is a y-intercept value, which is still pretty big. So I just mark over here 216 because it's too big. Okay, and the slope will be going down, going to the right, going down, going to the right. So going to the right 5 unit. It's going down with 9 unit. This is 9 unit. This is 5 unit. So the line will be like this. Okay. Excuse me. Okay. Excuse me. And this is greater than equal, so I have to share this part because greater than represent the upper part of the line of the coordinate system. So the x over here will represent the number. This is x value, so we represent the number of chicken here, and over the y will represent the number of bowl. Okay. Okay. For part C, it's like if he sells 50 plates, for part C, can she sell 100 chicken dinner and 130 bowl of goulash to obtain enough revenue to cover the expense? They say that if she sell 100 chicken, if she sell 100 and 120 bowl, and the question that if she sell that this many, it will be enough to cover the expense, which is $1,080. Okay, how we know it will be covered? Okay, we can plug it into the inequality to see. As long as it's greater than 1,080, it means we can cover that, right? It means that amount the revenue she earned can cover $10,080. Okay, so I'm gonna plug it in this inequality over here, which is 9x plus 5y greater than equal 1080. So x represents the number of chickens, so I put 9 times 100 plus 5 times 120. Okay, now it's 900 plus 600. Oh, okay, so they give me 1,500, and of course is it can cover the all expense, right? Because the revenue she make over here is $1,500. It's much greater than, it's kind of bigger than 1,008. So okay, so this the 1,500 will be the revenue. Okay, this the gross income. Okay, so it looked like that she can make and she can put let me see, I do the quick subtraction here, $420 in her pocket. Okay. 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 So basically, that's all the concept for linear inequality of two variable. All the exercise will be kind of the same as um, this one. Most of the practice problem will be graphical. You just need to graph linear equation, and you just set the right part of the coordinate system, the area of the coordinate system. Then that will be your solution. Okay. On the second part of the lecture, I will be talking about the system of linear inequality. System of linear inequality. Okay. Now if I take one linear inequality with two variables, for example, I'll take y plus 2x greater than 8. Okay, and I want to combine this linear inequality with another linear inequality, y minus x greater than 1. Then I have a system of linear inequality. So a system of linear inequality is just a combination of more than one linear inequality with two variables, and the solution of the system of linear inequality is a bunch of points on the coordinate system, and we can find a solution by graphing only. Okay, we graph the first inequality, okay, and we find a reason that satisfies the first inequality. Afterward, we graph the second inequality, and if we find a reason that satisfies the second inequality, then we find the overlapping region, overlapping area between two regions. Then those overlapping area contains a bunch of points that satisfy these two linear inequality simultaneously. Okay, so how we do it? Let's go ahead and do it. Okay, so I want to graph this linear inequality. I want to convert it into the slope-intercept form, because this is a standard form. Okay, so I go ahead and convert into slope intercept form. This become y greater than negative 2x plus 8, and y is greater than x plus 1. And I graph it. Okay. You do the same way as you graph when you find a solution for linear inequality with two variables. Okay. So I graph this one, and I know exactly that this one will be the dashed line, and this one will be will have the solid line. Okay. So it's slope intercept 8. 1, 2, 3, 4, 5, 6, 7, 8 right here. And I go down to unit, go to the right 1 unit. So it's gonna be like this. Okay. And I know this is greater than, so it must be above the line. So I set it above the line. Okay. And for the second inequality, I do the same thing, and I know this have a solid line. So we start at y-intercept value 1. Okay, and going up 1, going to the right 1, so it's gonna be like this. Okay, and I use solid line, and it's greater than also, so I set it above the line. Okay, and now of course, now you can see that two regions overlapping each other, right? And this is the overlapping region right here. Okay, so I will use a different color to represent the region. There you go. Okay. Okay. So this region contain a bunch of points. Okay, contain a bunch of points, include the point on this line up to here, from here up to all the way up, right? On this line will satisfy this a system of linear inequality simultaneously. Okay, and this is a solution. As long as you graph and you set it, then that will be the solution. We cannot write the solution of a system of linear inequality with two variables algebraically. So this is the solution already. However, sometime when we graph the system two linear inequality, and we set the region, and it never overlap each other. Okay, sometime maybe it could be like this. It could be like this. Okay. And if it never overlap each other, then the system of linear inequality has no solution. Okay. And of course, sometimes it overlap. The overlapping region is the whole thing. It could happen. It could happen that way too. Okay. All right. So I don't know if you have any question. Please comment under the YouTube video if you have any question. Okay. Next, I want to do a word application problem related to system of linear inequality. Okay. Example 2. I want to do the example number 3 on page 181. Okay. I will make a quick summary on the question. Andrea makes $10 an hour walking dogs and $15 per hour bathing dog. Okay, so $10 an hour for walking dog and $15 an hour for bathing dog. She is a full-time student and wants to be sure that this job doesn't interfere with her plans of graduate from college. Therefore, Andrea doesn't want to work more than, okay, not more than, so doesn't want to work not more than, she doesn't want to work more than 12 hours per week. Okay, so the total is no more than 12 hours, I mean that it's less than equal 12. Okay, how many hours does Andrea need to work at each job if she wishes to earn at least, okay, so at least $150 per week, and at least, you know, that must be greater than equal. Okay. All right. Solution. So how we do this? Every time we want to do a word problem relating to system of linear equation or system of linear inequality, we need to name the variable that represent what they looking for. Okay, what they want us to look for, or what they want us to find. Okay, so what they want us to find? They want us to find how many hours Andrea work at each job. So I mean, how many hours she spent on walking the dog, how many hours she spent on bathing the dog. Okay, so I call it X, represent the number of hours for walking dog, okay, and Y represent the number of hours, okay, for bathing the dog. Okay. Then after we name the variable that represent the thing they want us to find, we need to set up the system equation, and we try to see that we have enough information to set up the equation or not. And I feel that that's I read the question and I see that it's right away that yes, we do have enough information here, because we have less than equal 12, we have greater than equal. Okay, so the first equation, she doesn't want to work more than 12 hours, so the total is less than equal 12. Okay, then she making at least $150, so it must be greater than $150. And the amount of money she make out of walking the dog, we can find it by multiply $10 per hour. So X represent the total number of walking the dog, so 10X plus 15Y greater than 150. So we have a system of linear equality right now, and we can only solve it by graphing. Okay, so again, I will convert it into slope-intercept form. The only part we have right now is the numbers seem to be pretty big. The numbers seem to be really big. So I try to simplify that. So if you X 10, I simplify that and give you only 10 as the y-intercept here. Okay. I go ahead, graph it. The first one, so 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so 12 here, and going down 1, going to the right 1, so no, going to the left 1, sorry, oh, going down 1 to the right 1, so it should be like this. Okay, and the second one is, I start at 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right here, and going down 2, going to the right 3, so 1, 2, 3, so it should look like this. Okay, and all of them is above the line, so all of them is above the line. Equal is greater than. Okay, it's above the line. Let me see. This oh, this is less than. I'm sorry, it's less than. So below the line over here. Oops. So right here. The second one is above the line. However, this is below the line. Okay, so the overlapping region is this right here. Right here, see that? Of course, we have something over here, but in real world application, we don't have negative. We don't have negative amount of time walking the dog, right? So we have to throw away this part. Okay, we have to throw away the part we have. We get it from here, from the intersection point here up to here only. Okay, and this X over here represent the amount of hours she walk in the dog, and this represents the amount of hours she bathed in the dog. So all the point over here, as long as she satisfy all the point in here, represent the number of hours. So for walking the dog and bathing the dog, which satisfy the system equation, system of linear inequality. I'm sorry. Okay, so the amount of times you walk in the dog will be in this part from here to here. Okay, and the amount of times she bathe in the dog will be from here to here, from here to here. Okay. Okay. And so far we learned how to solve system of linear equality with two, we have two linear equality. Sometimes we have three linear equality, and we also do the same thing. Okay. And again, the solution for the system linear equality is any point is the overlapping area, overlapping region that represent all the points that satisfies the system linear equality simultaneously. Okay. Okay, so most of the exercises I have here kind of similar to the example I have in this video. I don't know if we can do one more example, or I try to find just the example or the problem that's different from what we already did here. Let's see. Okay. Oh, I just forgot to tell you, the intersection point over here represent the minimum. Okay, not the minimum, the maximum hours of the maximum hour for walking the dog, and the minimum hour for bathing the dog to satisfy or this inequality, or to help her to make more, or not help her to make at least $150, and help her not to work more than 12 hours. Okay. Okay, that's what the intersection, the vertex mean. Okay. It means that as long as she whatever over here, maybe over here 3, I have not found the intersection point yet. So as long as you she work 3 hours, for example, and as long as you work over here, maybe like 1, 2, 3, 4, 8 hour, maybe 8 hour here, then it will satisfy the inequality. It will help her to make at least $150, and it will make her not to work more than 12 hours a week. Okay. Okay. Okay, so basically that's all for the lecture today. All the problem and all the practice kind of similar. It will be very easy. You just grab and you find the overlapping region. Um, and if you go through all the practice problem, and if you have any question, you just let me know, and I will go through one by one if I can. Or if you have any specific question related to the topic we learned today, just put your comments under the YouTube video, then I will help you to find the answer. Okay, and next time I will start chapter 3. Uh, the textbook. In chapter 3, we're talking about a 6 basic function. We already we want to go through 6 basic. We want to investigate the domain and the range of those 6 basic functions. Okay. All right. Thank you so much, and I'll see you next time. Bye bye.